Hello everyone, this is Mr. Kozlowski and welcome to Learning Target 4 for Unit 4 on energy. We're finishing up Unit 4 and getting ready for the end of the semester here very shortly. And basically the last learning target in Unit 4 is energy calculations. Basically what you need to do is you need to calculate energy for the following energies: kinetic energy and gravitational energy, EK and EG. And the equations are as follows. So it's fairly straightforward learning target. You simply need to use both of these equations in a given scenario and calculate the energy for that specific type at a given point in time. So let me take you through the basics and just kind of give you some reminders here as to what you need to know for the upcoming exam and the upcoming quizzes as well. So let's start off with calculating gravitational potential energy. The equation is gravitational potential energy equals mass times the gravity times the height of the object. So if we look at this picture here, we have various points in this motion event. Okay, obviously this is a skateboarder that is moving from position 1 to position 3, so he's moving from left to right up the ramp, so to say. And then basically we have some data here. We know that the mass is 60 kilograms, and then we also know that the velocity is 8 meters per second. That's the speed. At position 2, he's at 1 meter, and then at position 3, he's at 2 meter height. So overall, if we look at what we have going on here, we have to calculate the gravitational energy at a specific point. And how we do that is simply using this equation. So if we have EG is equal to M times G times H, let's calculate for position 3. A few things here. Number one, we're going to be a little more strict on solving these equations. So you have to show your work. So the next step is, or basically the first step is to show the equation. The second step here is that we want you to plug in the values that you have. So the first value that we're going to calculate for this in this equation is the mass. Well, the mass is equal to 60 kilograms. So we're going to write that, and when we write that, I'm not just going to write down 60, I'm going to put the units in there. And right now, for being a freshman, the units are not necessarily important to understanding what you get for the final unit, but when you get into things like chemistry and physics, you must understand what units go together to make another specific unit. The second value that we have is 9.8. That's the measure of gravity, and that's actually a unit of acceleration, so we're going to put meters per second squared there. And then the height. Well, position 3, the height is 2 meters. Alright, so basically that's step 1 and 2 together. Step 1, list the equation. Step 2, you're going to plug in the values that you have for that specific equation. Step 3 is to solve for the equation. So what we're simply going to do, this is all multiplication. You're going to take 60 times 9.8 times 2, you're going to plug that into a calculator, and you should get this units. This answer, it should be 1,176. And for that answer, if we plug that in, that unit is going to be joules. So the units of energy is joules. We represent that with a capital J. You spell it like this, Joules, and that's the unit we're going to use for energy. So that's the answer, and I always do step 4. I tend to box my answers so I know that that's the value we're looking for in the equation. You must have all of these steps in order to solve for a proper equation, and this not only applies to the energy equations that we're going to talk about today, but it also applies to other equations that we've talked about in class. So just get in that habit of filling out those equations properly. The other type of energy you're going to be responsible for solving for is kinetic energy, EK. And the equation is a little bit different, And if we look, the equation is EK is equal to half the mass times the velocity squared. So again, a little bit different here in terms of order of operations. I know you're probably thinking, oh, this is math class. Yeah, it basically is. It's simple algebraic equations. And what we're going to be dealing with is we're going to be solving for EK. So again, step one, what's the equation? It's EK equals a half times the meter, or times the mass times velocity squared. And I know that's poor handwriting, so I apologize. But let's get to step two. Step two is plug in that value. So EK, let's solve for position one. All right, position one, we know it's going that fast at that moment in time with those data points. So take a half, and I'm going to put that in parentheses. I'm going to say the mass is 60 kilograms. And then the velocity or speed is going to be 8 meters per second. And that value is squared. So again, order of operations, what we're going to do, we must square that. So if we square that first and kind of solve for this, EK is half times 60 kilograms times 8 times 8 would be 64 meters per second squared. And then we take that and we plug it in. Step three, let's solve for it. EK would be half of that value. So I got, again, half times 60 times 64. That would be 1,920 joules. Okay? So, again, box that. I like students to box that so they know this is your answer I should be looking for if I'm looking for it. I will be looking at your work coming up when we solve these equations that we have up here. So again, please be vigilant of that. All right. So some things, again, to remember for energy calculations. Again, we have to be able to identify between gravitational potential energy and kinetic energy. Again, gravitational potential energy is the energy involved with the change of position or height. And then kinetic energy is actually energy of motion. So please be aware of that. And then finally, show all your work. Those steps I outlined and used in solving for those equations are what the expectation is, not the exception. All right. So we expect you guys to, again, be vigilant of units, be vigilant of plugging in and following those steps. And then finally, units are important. This is true for any equation that you calculate. So please be aware that we are stressing that you write down your units, and that's going to help you be better in calculations, not specifically in science, but also in math. If you understand where the units are derived from and where they come from, it's going to make things much easier in biology, chemistry, and also physics once you get there. So again, if you have any questions, no quiz for this one as well, because I know we're working hard to get prepared for the final. So please let me know if you have any questions, and we'll discuss this more in class. Have a good day.